Welcome all. My name is Dr. Manoranjan Oja. I am the Assistant Professor, Department of Basic Science, Chemistry, SR University. Today's topic is laser. We'll discuss the principle and characteristics of the laser in this tutorial. What is the meaning of the laser? So laser stands for light amplifications by stimulated emissions radiations. So light amplifications by the stimulated emissions radiations, that is called the laser. So we'll discuss one by one what is the meaning of it. So first we'll see in the very broad way that what is the laser light and the normal ordinary light. What is the difference between it? If you see here in right hand side the ordinary light, where in left hand side is called laser light. If you see here, laser light is pointed narrow and in particular directions, where intensity is very high. Whereas if you see the ordinary light, it is in a over a region, so or it is distributed over in different parts. So it is more concentrated, and normal light is distributed. So this is the main differences if you observe qualitatively from the outside, the difference between the laser light and the normal light. So we'll discuss that what is the why it is the behaving different way, the laser light than that of normal light, and what is the applications and advantage of using the laser light and the mechanism how it works. So this laser light, when we are getting in a device, actually it's have a very intense and coherent. Coherent means it's same phase. That light it's emitting that light that is in same phase, and monochromatic means in only one wavelength the light is available, and highly directional beam of electromagnetic radiations means in one direction always. It is not distributed overall in the space, but here if you see normal light, it is distributed in overall. So it is very directional. This is not a directional. Normal light is not a directional. Right, these are the difference between the laser light and the normal light. So if you see that normal light emits the light in multiple directions, that is, it is spread in overall this region. But where is that for the laser light in only particular one region we see, and different kind of a wavelength will be wavelength of the light will be observed in the normal light, whereas for laser light is a particular only one wavelength of light can be seen. So this is very important because we are using this one in different in different fields, that is called medicine, industrial, communication, or defense. So that's why it is much more a very important topic we are discussing here, the laser, how it works and what is the applications of the material. Right. So first, to understand the laser principles, so we discuss that how that atomic behavior, electronic transitions of a atom, how it happens. Normally, if you say then an atomic nucleus, then perfect in energy, there will be electron is revolving around the nucleus. So this energy level, every electron staying in this energy particular state energy level, they are having the perfect energy level, very specific that is. So when we are using some kind of a radiations or energy, then this electron in one level state can move to the higher energy state, in that absorbing that much of energy. Then after that, when it high energy of the electron will stay in that stage, so it can emit the radiations that is called photon. So photon can be emitted by the higher energy state electrons. Now this is the creations of the photons of the molecules. In a similar way, let's say what is happening in the molecule. When, let's say, in a molecule, it is in the valence band, electron is there, and the conduction band or higher energy state it is there. Let's say conduction or something. So now, when these electrons on the valence band, it is full of electrons. So it absorbs the lights or the energy from the outside, not only the for light, maybe for mechanical, maybe for electrical, or maybe for photon or photon. So it will absorb the energy, then electron will be excited, and then it will go to the higher energy state. And this process is called absorption. So this is the high energy state, that is called, let's say, S1, this is S0. So electrons in the ground state, it will absorb the energy, then it will go to the higher energy state. This process we call is the absorption process. Right. In the opposite way, when the high energy electron come back to the ground state, then it will emit the energy that called photon. So this process we call the emission process. Now, let's say we are energizing one system or molecules or a compound, but using the energy that may be form of photon, or maybe light, or maybe some mechanical, or maybe some thermal way. We are energizing the system. Then electron in the ground state, it will go to the higher energy state. So due to the absorption process. After that, how it will come back to the ground state. So the process of the coming the electrons from the higher energy state to the ground state, it's called the emissions process. But how it is coming, the emissions is how it is taking place. If randomly from higher energy state, this is low energy state, the LS lower energy state, and HS is the higher energy state. If electron is coming from higher energy state to the lower energy state in randomly, so it is emitting the light with randomly or in different directions, then this called is spontaneous emissions. That any directions that can be happened, that it is emitting the photons. So this is observed for conventional lights. When we are hitting it, the system, it is going to the higher energy state and coming back to the ground state by emitting the photon in different directions on various directions randomly. So this process is called spontaneous emissions process. Right. So it is also non-coherent light because it is spontaneously randomly in different directions this photon emissions taking places, and the phase of the photons also different, not a single phase. So that's why incoherent light is observed for the spontaneous emissions. Now second step, that if it is that limiting the photon is happening in a particular directions or in coherent light, a coherent way, or maybe or in a constant phase, then this process we call the stimulated emissions process. So that is the fundamental how the laser process or laser light, the mechanism happened in the laser light. So how it is happening, that let's say in the ground state it is going to the higher energy state, then from the higher energy state again it is coming to the ground state in a particular wavelength and particular one directions in coherent in particular one phase. If it is meeting this all criteria, then only we will get the laser property of the molecule, or we can say that emission is happening in the laser compound in these principles. So means it is in same phase, it is traveling the same directions and having the same polarization. Polarization means it is that electric field is in one direction. So this is called the polarization, same polarizations of the light. So we'll discuss a little bit more that how it is happening, that emitting photons, how equal sign, how the process is happening, the mechanism we will discuss in the here. So what is happening, for example, that for lower energy to higher energy, the transitions is happening, we are promoting the electron from the lower energy to higher energy. Then we apply it from outside, we are stimulating it by applying on the outside with photon in higher energy state. Then what the electrons is there in higher energy state, which is unstable, it will interact with the photon, then it will generate one more photon and then come to the ground state. So again, what is happening, we'll discuss that from the ground state, electronic transitions happened into the higher state by the means of energy excitations. Then in the excited state, which is unstable, there we are providing a photon. Now photon will interact with the high energy electron. Then this high energy electron, what will do, it will emit the photon and then come to the ground state. But this photon it emits in the excited state has the same behavior or same property with the interactions of the photon. So one photon came to interact with the higher energy electrons, and then what it did, that high energy electron produces the photon which is exactly same behavior of the previously interacting photon. So this process takes place in the laser. So then one photon, when it is coming and interacting one electron, then another photon is created. So one photon, it's coming, creating two. Then when two photon is there, then it is creating four. Then four photon is there, then creating 8, then 32. Like this, the process goes on. So these are where the number of photons is created in the molecules. Now, for these interactions with the photon with high energy electrons, and to create the more photons overall, we need more in high energy electrons, unstable electrons in the high energy state. So for that one, what we need to do, we need to provide the materials high energy excess that maximum electrons should come to the higher energy state. Normally for any compound, all the electrons stays in the ground state, that is lower energy state. But what we need to do, we need to provide this energy to the molecules that the maximum electron can come to the excited state. If number of maximum electrons coming to the excited state, then these interactions of the photon and excited electrons will be much more higher. The number of the photons will create more, then we will get the good laser properties. So what we need, that we need number of more electrons in the higher energy state. So when we are doing this process, this is called population inversions. Means we are making more number of electrons in the higher energy state. So this process is called the population inversion stage. So how we are doing this? We are pumping mechanism we are using. So pumping mechanism means what we are using here, that we are providing the energy to the system to establish or to making the more electrons in the higher energy state. By what? How? By using the flash lamp, or this energy source I am using, or electrical pumping, or chemical pumping, or electrical current injections. Some kind of energy we are providing, that what we want, that we want more number of electrons in the excited state than that of the ground state to make the population inversions. Then when number of the electrons will be in the excited more, then by providing the photon outside, it will interact more with the high energy electrons in the excited state. Then it will create much more the photon, then laser property will get it. Optical resonator. That optical resonator is that after the interacting with the photon, that photon can rebound in the excited state, like we have a two mirror. One mirror is for fully reflecting, another mirror is partially reflecting. So it is just bouncing between two mirror. Then this is it is amplifying in these photons to get the laser properties. So why we are using the partial reflecting? Because partial reflecting will also allow some part of the photon will pass out or it will pass through the mirror. So then it will show the laser beam. It will form the laser beam. Or others that mirror fully reflecting mirror, and it will just rebounds from that mirror, so that that implication amplifications of the light will be much more higher. So that is where there two mirror is used. One is fully reflecting, another is partially reflecting. So we want two things. One thing is we want that amplification should be higher, and then we also want the some amount of photons should pass through the mirror, so to generate or to get the laser beam. That's why we are using fully reflecting mirror and partially reflecting mirror. So what is the component of the laser system? So there are different type of the component in the laser system, that is called effective gain medium. So that the gain medium, it is used for different, for the, let's say, solid, ruby, or gas, or liquid. So this is the medium where that laser effect or some stimulated emissions is taking places in this material. So what is the pumping source used? Pumping source is used for making the population inversions. That is different kind of a system. What we are using, that supplying the energy to higher excite the atom in the gain medium. So it means that gain medium means what is the material we are using. That material we are exciting this material in a higher energies to promote the electrons from the ground state to excited state. For this one, we just discussed the flash lamp or electric discharge or laser diode. These are being used for pumping source. Optical generator, for this one, what we are using is the quality of the laser beam. So means how intense it is or then concentration it is, and there's also the direction way. So all those determined by the optical resonator. That mirror we are using two types of fully reflecting and partial reflecting mirror. And that what is the characteristics of the laser light, then that of normal we just discussed earlier as well, that what are those the characteristics of the laser light. So first thing is that we will get the light which is monochromatic, means only single wavelength of the light will be there in the laser. That is called monochromaticity. So only one wavelength of the light will be observed. This is being used for the spectroscopy or holography applications. Now what is coherence is that it is a only one phase, so constant phase relationship among the laser wave. So what are the wavelength it will generate? Only single monochromaticity, only one wavelength. The phase will be same. So for example, let's say this is the one light wavelength it is coming. So phase will means all the light will be exactly same way it will start and it will go. So it won't start here or like this, it won't go. So when it is starting here, so this may be there is a phase differences is there. So this phase difference should not be there in the compound. So this is called in the laser, that is called coherence. So there is no phase differences. So constant phase should be there for all wave. So there are two types of the temporal coherence or the spatial coherence. The spatial temporal coherence means that this phase, the constant phase, always it will be consistent over the time. Means over the time you can't see any, or you will not be observe any differences in the phase. Or another is called across the beam, that is called phase consistency. Across the beam there should not be any change, or that will be constant. That is called spatial coherence. Right. So what will be why it is required? Required for the holography or interference experiment or precision measurement. These are very essential criteria for this coherence properties. Directionality, another one is called directionality. Directionality means you see that in particular direction the light will come. Then it is not over the area, it is distributed. So in different directions randomly this light won't come. That is called directionality. So in normal light you will see that it is spread over the region, but in laser light only particular directions will get the light. So this is called the directionality of the lasers. High intensity. High intensity means light is very much concentrated in small area, number of beams will be very high. So that is called the intensity. And if it is intensity is more and producing very high energy density, the energy density will be much more higher, which is be used for metal cutting, welding, or laser surgery or material processing. Polarizations means in a particular direction, then degree of polarizations will be controlled by this a laser cavity. So in, let's say, in a light there will be electromagnetic field that is in a particular direction. So when the electromagnetic field will be in a particular one direction, then we call is this highly polarized. If a direction is changed in a different way, then it is called a non-polarized light. So in particular plane, if the electric field is moving, that is called highly polarized light. So these are the properties for the laser. Type of the lasers are the means in what type of the lasers is used. There's solid state lasers. So this is used, this is can be seen for solid state compound, the ruby laser, or here NDYAG laser. This is a rare earth materials used in for the lasers. So this is being used for the medical treatment or cutting or welding operations. So this is a one solid state laser. Gas laser also is examples there. Helium neon laser, so CO2 laser is available. So which is commonly used for alignment system for barcode scanning or surgery purpose. These are the gas lasers which is being used for the barcode scanning or surgery purpose. And for semiconductor compound also shows the laser properties. For this is called a laser diodes, widely used for optical communication systems and also for CVD or DVD players. There we use the laser that is called the semiconductor lasers. Right, and liquid dye also shows also laser properties, that is called laser provided to enable tunable wavelength, means we can change the wavelength of the laser. So different color of the laser also will become red color or green color or yellow color. So due to changing the color, the wavelength of the light, that is being used for scientific research or spectroscopy. So what are the advantages of using the laser? So actually this is very high precision, so we can use for the instrument and for study, which can get the result, which is very highly precision result we can get it. And non-contact operation, so we do not need any contact, so directly we can get it. And as it is a precision is very high, so accurate we can get the data, and energy output, controlled energy output, long operational lifetime as well, and wide range of the application. I will discuss one by one that which the field the applications can be used for the laser. These are the advantages of the lasers and the applications of the lasers. So one applications of the laser is called the medicines purpose. So for example, laser surgery, eye treatment, or dentistry. So this is used for the laser treatment. So one example of dentistry, one that let's say we have done the root canal for the teeth, that there will be some hole that we have removed that root and made the root canal treatment. Then what sign doctor used to do to fill that canal with a compound. So they used to use the polymer. So what they used to do, they will fill one kind of the polymer in that canal. Then they will treat that polymer with a laser light. So when they use a particular laser light, that polymer will absorb the laser light, then polymerations will takes place on that compound. Then it will become within seconds harder. Whether hard means like a stone type or metal, stronger as that kind of a metal. So this is used for the dentistry. So means one compound they are using, but using the laser light, this compound undergo polymerization so rapidly within seconds, then it becomes so much strong as kind of a stone or kind of a metal type. So it can't be break. So this is one is used in dentistry. Otherwise, medicine application also is being used. That is called eye treatment or laser surgery. Now, industry also has been used. That is called cutting purpose, welding purpose, or engraving purpose. These are the purpose in industry. This laser light has been used for communication purpose, also for optical fiber transmissions. So this has been also used for the laser light. For research purpose for spectroscopy, holography, or interferometry. So in that case, also in science, laser light has been extensively used. And for defense purpose, for defense range binding or guidance system, is laser light has been used. Consumer electronics for printers, scanners, optical storage system. For those purpose also laser light is being used. So if you see in a vast field of the field, this laser laser application is there. So it is very important topic that where in very vast field of the materials has been used in different purposes. So what we discussed in this topic is that how the first what is the laser, then what is the difference between the laser light and the normal light. So this we discussed. So what are the points that laser is completely different from the normal light? That is, it is a directional, it is emitting only one wavelength, it is in constant one phase, and intensity or concentration is much more higher. Whereas that for normal light, it's spread over the region, it is not directional, and also wavelength also not single wavelength light is emitted, and also it is not a coherent, means electric field may be vibrated in different plane, not in a particular. And these are the major differences between the simple normal light and the laser light. Now the mechanism also is completely different in the laser light that we have discussed here. That we need some stimulation photon, that it will stimulate the high energy electron to generate a photon which is similar to the interacting photon. Then this photon will can be amplified to get the more photons, then we'll get the laser behavior of the materials. So for that one, we need a population inversion, means we need much more electrons in higher energy state. So what we'll do, we'll provide the much more energy for the system, and we'll convert or we'll transfer the ground energy, ground electrons to the higher energy, to the higher energy. So number of the electrons will be much more higher in the energy state than that of the ground state. That will make this sure. Then the interaction of the photon with the higher energy electrons will take place. Then this will get the amplifying this photon to create the laser light. So these are the mechanism it works on the laser light. So we also discussed that what is the properties of the it is having in the laser light. That is a monochromaticity, means only one wavelength of the light it is the wavelength of the light wavelength of the light will be there inside the laser. And also we discuss what is the applications and the advantage of the using lasers. So advantage we have seen that it has been using different kind of application, that in scientific or industrial process or medical communications optical fibers also we have discussed this. So this is a very important topic because its applications is very vast and very different field it has been used, and it's for also research in scientific way it has been also used. So these are the topic we are discussing here in the laser systems. So we discuss is the laser properties here. What is the lasers and what is the advantage, and also that which field it can be used. Okay, so we'll stop here.